Hi guys, welcome to my YouTube channel. If you're new, you're welcome, and if you're old, you're super welcome. This video shows a step-by-step method of performing unpaired two sample t-tests having equal number of observations. In two sample hypotheses, we are dealing with two sets of samples instead of one, and two types of tests are applicable. One, the unpaired t-test, and the paired t-test. For the purpose of this video, we're going to concentrate on unpaired t-test. The unpaired t-test is often used in biological research when there is no basis for pairing. For example, the comparisons of physiological and morphological parameters in males and females. Alright, the question now is, how do we perform two sample unpaired t-tests? Alright, we'll answer this question with the example we have on the bar. But before then, do well to subscribe to my channel, turn on the notification bell, hit the like button, and share this video. Thank you. The question says, an experiment was carried out on some patients to test whether a new medicine is more effective in reducing blood pressure than the current one. After 3 months of consuming the drugs, the amount of reduced blood pressure for the two groups was recorded and shown below. Test for the significant differences between these two samples at 0.05 probability level. This table shows the reduced blood pressure for this patient. For group 1, we could see the reduced blood pressure after 3 months of consuming the current drug, right? While the group 2 shows the reduced blood pressure for these patients after 3 months of consuming the new medicine. And so, we have various steps of testing whether the new medicine is more effective than the current medicine. And here we go. Step 1 says, state the hypothesis. Of course, we have a null hypothesis, a H0, which states that the new medicine is equivalent to the current medicine, right? So what null is simply saying is that the new medicine and the current medicine has equal effect in reducing blood pressure, right? So next is to state the alternative hypothesis, which states that the new medicine and the current medicine are not equal, right? So what the alternative hypothesis is saying is that the effect of the new medicine and that of the current medicine are not equal, right? Alright, step 2 says determine the confidence interval. That takes us back to our question. Alright, looking at our question, we could see at 0.05 probability level, right? So we represent that with our alpha equal 0.05. So what this simply means is that there is 95% confidence that the conclusion of this test will be valid, right? Alright, this step says determine the sample size for each group. Of course, that takes us back to our table. Alright, looking at our table, we could get a sample size by count, right? And here we go, 1, 2, 3, 4, 5, 6, 7, 8 for group 1, and then for group 2, 1, 2, 3, 4, 5, 6, 7, 8. So they both have the same sample. A sample size designated with n for the first group n1 equal 8. So this step says determine the degree of freedom. Of course, here we're talking about unpaired two sample t-tests, and so our degree of freedom will be n1 plus n. Of course, the value of n1 and n2 are equal. So we have 8 plus 8 minus 2, and then 8 plus 8 we have 16 minus 2, of course that gives 14. So our DF, degree of freedom, equal 14. And then this step says determine the sum of each group, and that takes us back to our table. For sum simply means addition, right? So for the group 1, we have to add 5 plus 3 plus 6 plus 5 plus lastly plus 4, and that gives us 36, right? And so we have summation S1 equal 36, right? Followed by 8 plus 11 plus 2 plus 10 plus 8, lastly plus 3. So here we have summation S2 equal 51, right? Alright, this step says determine the average value of each group. Average simply means the mean, right? So the mean for the first group, we have S bar 1 equal summation S1 over N1, which is the value for summation S1 we had 36 over N1, right? The sample size for group 1 we have 8, and here 36 divided by 8 gives us 4.5, right? So next will be the average for the second group. We have equal summation S2 over N2, right? Where the S2 is 51, so we have 51 over N2 being 8. Of course, 51 divided by 8 gives 6.375, right? This step says generate values for the square of each group and also determine the sum. So that takes us back to our table. We are instructed to determine the square of each group. The square for the first group, we'll call it S1 square, and here we go. 5 square gives 25, right? Next, 3 square gives 9. We have 9 here. 6 square gives 36, right? And lastly, 4 square gives 16. And so summation of all these values, 25 plus 9 plus 36 plus 25 plus 16 plus 49 plus 4, and lastly plus 16 gives summation S1 square 180, right? So moving forward, we also expected to get the square for group 2. Call that S2 square. And so for the first one, we have a square. So a square gives 64, right? Followed by 11 square gives 121, right? 2 square gives 4, and lastly 3 square 9, right? So we have to add up these values, right? So 64 plus 121 plus 64 plus 25 plus 16, and lastly plus 9, that gives 403. So summation S2 square equal 403, right? Alright, this step says determine the sum of squares of each group, right? So let's take the sum of square for group 1. I call that SS1 will be N1 times summation S1 square minus summation S1 square, right? Alright, where the value of N1 is 8, right? The sample size. So we have 8 here, 8 times summation S1 square 180 minus summation X1, of course, we have 36 here, right? 36 all square, right? 8 times 180 gives 1440 minus 36 square gives 1296. All right, we have 1440 minus 1296. So our SS1 would be 144, right? So let's get the sum of square for the second group. SS2 would be N2 summation S2 square minus S2 square, right? So following the formula, N2 value is 8. We have 8 here times summation X2 square. Let's go. Summation S2 square, we have 403, right? 403 minus summation X2 all square, right? So let's go for summation S2 and look at the value we have. So we have 51 all square, right? So here we have 8 times 403. We have 3224 minus 51 square. 2601, right? So 3224 minus 2601, we have 623, right? Step says determine pod variance, right? So we present that with sum of square for group 1 plus sum of square for group 2 divided by the degree of freedom. Would be sum of square for group 1, we have 144 plus sum of square for group 2. For group 2 we have 623 divided by the degree of freedom. So let's check out the degree of freedom again. Of course, our degree of freedom is 40, right? So 144 plus 623 gives 767 over 14. So 767 divided by 14. So our pod variance would be equal 54.786, right? It says determine the standard error of difference between means, right? And we represent that with, so since the sample size for the two groups are equal, our standard error would be 2 times pod variance over n, right? And of course that would be 2 times the value of our pod variance is 54.786, right? Over the sample size we have 8, and so 2 times this gives 109.5 divided by 8. Of course 109.5 divided by 8 gives, we have 13.687. So root 13.687 gives approximately 3.7. So 3.7 is the value of our standard error, right? It says calculate t by applying the formula, and the formula goes to t equal the mean of the first group minus the mean of the second group divided by the standard error of difference between means, right? So let's look at for the mean of the first group and the mean of the second group. Here we go. All right, the first group has 4.5 as its mean, while the second group has 6.375 as its mean. And so we record that now over the standard error of mean of difference, and we got 3.7. So we have 3.7 here, right? And so 4.5 minus 6.375 gives minus 1.875, right? Divided by 3.7. This divided by this gives, so our t, I call it t calculated, will be equal minus 0.51, right? Next, check for t critical from the t distribution table, and that takes us to our t distribution table. And here we go, and here we're expected to look out for t at 0.05, right? Of course, we're talking about two sample unpaired t-tests and degree of freedom 14 by our calculation, right? And let's trace that two tests here, looking at 0.05, degree of freedom 14. Of course, here is 14. So our t value is 2.145. So we report 2.145, right? Next says accept or reject hypothesis, right? So accepting or rejecting hypothesis simply depends on t calculated and t critical or tabulated, right? And the rule is when t calculated is less than t tabulated, you accept null and reject the alternative. And looking at our values here, t calculated is way less than t tabulated. So here we accept null and reject the alternative. Lastly, we're expected to draw conclusion. All right, our conclusion will be based on the fact that we accepted null, right? So we are to look at for what null says. All right, null says current drug and new medicine are equal, right? So we are to accept this hypothesis, right? And so we report that there is no significant difference between the current drugs and the new medicine, right? At P greater than 0.05. So we basically drawn a conclusion that the current drug and the new medicine have similar effect in reducing blood pressure. Thank you so much for watching this video. Please don't forget to subscribe to my YouTube channel, turn on the notification bell, hit the like button and share this video. Thank you. Bye.